Hello students! Magandang hapon, my dear learners. I am teacher Shella Dandan of Atty. Orlando S. Rimando National High School, Mako North District. Welcome to another math exciting lesson in mathematics. But before that, let me congratulate you for a job well done on the previous semester with general mathematics. How about giving yourself 3 claps? 1, 2, 3. Now, in the second semester, let us together explore the world of statistics and probability. But don't worry, I am here again to help you. Can you still recall our lesson in Module 1? Very good! It is about random variables. Today, our goal is to illustrate the probability distribution for a discrete random variable and its properties. Calculate probabilities corresponding to a given random variable. And illustrate the mean and variance of a discrete random variable. You may already have encountered this certain topic before, but let's learn more about how this can be used in our daily life. Are you ready? Let's go! You may have seen in the television or internet that someone won the lottery. The chance of winning it is very slim. You may consider it as a luck. The number of tails in a toss coin, winning in gambling, and hitting the jackpot in the lottery can be estimated using probability. We are using probability in real-life applications such as engineering, economics, and many more. Let us find out how exciting probability can be. A probability distribution of a random variable x describes the probability associated with the possible values of x. The probability distribution of a discrete random variable defines the probability of each possible value of the random variable. Its distribution functions are concentrated as a mass for a particular value and also known as probability mass function. Let us be reminded by the following properties of discrete probability distribution. 1. The probability of each value of the random variable must be between or equal to 0 and 1. In symbol, 0 is less than or equal to p of x and less than or equal to 1. Number 2. The sum of all the probabilities of all values of the random variable must be equal to 1. In symbol, we write it as p of x equals 1. Let us have an example to fully understand. When you have a coin and you want to flip it twice, it is possible that you cannot get a tail in 2 tries. Another possibility is that you will get a tail on the first try and a head on the second try, or a head in the first try and a tail on the second try. This probability represents getting 1 tail in flipping a coin twice. Another possibility also is getting 2 tails on your 2 tries. We already have presented all the possibilities of getting a tail by flipping a coin twice. Let us now calculate its probability. Since getting no tail in flipping a coin can only happen in 1 formation, and we have a total of 4 possibilities, so its probability is 1/4. Getting 1 tail can happen in 2 arrangements. Either getting a tail on the first try or getting a tail on the second try. Thus, our probability is 2/4 or 1/2. And lastly, getting 2 tails in flipping a coin twice can happen only once. So, its probability is 1/4. Thus, all the presented probabilities proves the first property that a probability of a random variable must be between or equal to 1. 1/4 and 1/2 is between 0 and 1. When we add all those probabilities, 1/4 plus 2/4 and 1/4 equals 1. It satisfies the second property, which states that the sum of all the probabilities is equal to 1. Probability distribution can be graphically represented by making a type of bar graph, which is called probability histogram. Histogram can be made by presenting the possible definite values of the random variable along the horizontal axis. We draw a vertical bar above each value x of the random variable, having equal height of the probability p of x. Example: write the probability mass function of the random variable x described by the results of rolling a fair die and create its suitable histogram. Since a die is fair, each of the 6 results has a probability of 1/6, or about 0.17. Therefore, the probability mass function is, when we illustrate it in a histogram, it will look like this. The possible definite values is represented by x in the horizontal axis, and the probability is in the y-axis. As shown, there is just an equal probability of all the possible outcomes as we roll a die. Did you learn something? Good job! Keep up the good work. Now, we will proceed to the next part of our topic. We will know deeper about the mean and variance of a discrete random variable. You can do this. Let's go! The mean of a discrete random variable x is described as a weighted average of the possible values that the random variable can obtain. The mean of a random variable weights each result x sub I with respect to its probability p sub I. The other term of the mean is expected value and has a common symbol of mu. The mean can be defined as mu of x equals x sub 1 times p sub 1 plus x sub 2 times p sub 2 plus and so on x sub n times p of n, or mu of x equals summation of the product of the possible values of a random variable and its probability, where mu of x equals the mean, x sub I equals the random variable, and p sub I equals probability. Let's have an example. In Panabo City Basketball League, each player shot 2 free throws. The number of free throws made by each player is shown by the following probability distribution. What is the mean of the probability distribution? Now, let's solve this. Mu of x equals summation of x sub I times p sub I equals, now let's substitute. Mu of x equals 0 times 0.15 plus 1 times 0.6 plus 2 times 0.25. Therefore, the mean of the probability distribution is 1.1. The variance of a discrete random variable x measures the increase or change of the distribution and can be determined by this following equation. The variance is equal to the summation of quantity x sub I minus mu of x squared times p sub I. Also, the square root of the variance is called standard deviation, represented by this equation. Let's have an example. Based on the previous example, what is the variance and standard deviation of the probability distribution? Now let's solve. Variance is equal to the summation of quantity x sub I minus mu of x squared times p sub I. Let's substitute. Quantity 0 minus 1.1 squared times 0.15 plus quantity 1 minus 1.1 squared times 0.6 plus quantity 2 minus 1.1 squared times 0.25. Now, the variance is equal to 0.39. And our standard deviation is 0.62. Therefore, the variance and standard deviation of the probability distribution are 0.39 and 0.62 respectively. Therefore, our variance is 0.39. To get the standard deviation, let us get the square root of 0.39. Thus, our standard deviation is 0.62. Now, let us practice. Determine the mean, variance, and standard deviation of this probability distribution. Wow! That concludes our topic for this module. It is very easy, right? Probability is a very important part of our daily life. It helps us to know about certain things better that can be applied in real-life situations. Statistics and probability can be very easy if you just know the basic principles and practical problems that may enhance your knowledge. Practice makes perfect. Always remember, you can do it. Again, I am teacher Shella Dandan of Attorney Orlando S. Rimando National High School, Mako North District. And I hope I made your lesson in mathematics math-dali today. Dahil dito sa TV Eskwela, sa pag-aaral, sama-sama. Bye-bye!